Restub sits as he's putting on the Ritz. So this is a Unit 6 problem. It's number 5.2. It's the early world of forces and looking at net forces, or the sum of forces acting. And in the distant future of a distant past, in it, SpongeBob still reigns Fry Chef supreme. And in this problem, what we have is a 1/8 pound Krabby Patty, or an 1/8 kilogram Krabby Patty, 0.125 kilograms. It has two forces acting on it to determine its horizontal motion. Okay, so let's just draw a picture. Here's a Krabby Patty. Whooshing. Looks like a hockey puck. It's got two forces acting on it. A 2.3 Newton force pushes it to the left, so something's pushing it to the left. And a 0.8 Newton force pushes it to the right. Okay, and we're going to take right to be positive, so this direction's positive, this direction's negative. What's the net force acting on it, and what's its acceleration? Well, just for completeness here, and because I'm a bad picture drawer if you couldn't tell, let's draw a free body diagram. So this dot represents the entirety of the Krabby Patty here. And when we draw our free body diagram, our forces come off of it from the center. So here's our 0.8 newtons in the positive direction, and in the negative direction comes our, and we'll draw this better to scale, we'll draw our 2.3 newtons, and that's in the negative direction, so it's negative. So if we're just trying to find the net force acting on it, the net force is just the sum of our forces vectors, and we just add these together because we're just looking at the xy directions, or the x direction here, just the x direction. So our positive 0.8 newtons plus negative, so that's minus 2.3 newtons, well, that's going to equal negative 1.5 newtons of force acting on a Krabby Patty. Okay. If we wanted to figure out what is the acceleration in part B, so here's part A, and part B, what's the acceleration? Well, we know that the sum of the forces, or F net, equals the mass times the acceleration of that Krabby Patty. So if we know the force here is negative 1.5 newtons, and we know the mass of the Krabby Patty is 0.125 kilograms, we can go ahead and solve the acceleration here. And when we do this, we simply divide by 0.125 on each side. And this will give us an acceleration here, which is negative, which makes sense because we're accelerating in the negative direction of, and we throw that into a calculator, negative 12 meters per second squared. Okay? So those are two answers there, and that's what we're doing. Just a basic little F equals ma problem. We drew out a picture, just like Grandpappy Bottser taught us. We took a look at the summation of our forces, which ones are positive, which ones are negative, and for acceleration we just used F equals ma, thinking about the net force, or the sum of those forces, to use for that equation. Okay, so not too bad, pretty straightforward one, and this is finished. We'll take a look at some more examples as we go along, but for right now, adios, and take it easy.